In this video, we're going to discuss instrument calibrators and show you how they can be used in the process control industry for calibration and troubleshooting. Okay, so what is calibration, and what is an instrument calibrator? If the quantity being measured is not being accurately represented by the measuring instrument possibly requires calibration. We can replace the quantity being measured with an instrument calibrator. Calibration can be carried out by comparing the readings on an instrument with those given by the instrument calibrator. Instrument calibration is an adjustment or a series of adjustments performed on an instrument to ensure that the instrument readings accurately represent the quantity being measured. Instruments require calibration for many reasons. Equipment degrades over time. Anytime maintenance is performed on an instrument, it needs to be calibrated. Often, the range of an instrument is changed, thereby requiring calibration. If faults are found and repaired as a result of troubleshooting, quite likely any instruments that were included in the troubleshooting process will require calibration. There are many different instruments used in process control, so there must be different calibrators as well. Let's look at a few different types of instrument calibrators. Block or dry well calibrators are used to calibrate temperature probes such as RTDs and thermocouples. The temperature sensor is placed in the dry well calibrator. A metal block is heated and held at a precise temperature. A fluid bath calibrator is similar to a dry well calibrator as the temperature sensor is placed inside. The big difference is the sensor is immersed in a fluid that is heated and held at a precise temperature. Pneumatic calibrators provide regulated pressure as needed to calibrate, test, or troubleshoot pressure instruments. One of the oldest and most accurate pneumatic calibrators is the deadweight tester, or DWT. A DWT will likely be found mounted permanently in the instrument shop. The DWT has several dead weights, which are precisely calibrated in pressure units. A DWT reaches a float condition when the upward force generated by a manual pump is balanced by an equal and opposite downward pressure from the deadweight that sits on top of a piston. When the piston floats, the instrument under test can be calibrated to indicate the pressure stamped on the deadweight. Another type of pneumatic calibrator is the handheld aspirator. A scissor-like grip adjusts the output pressure, and a digital gauge indicates the pressure readout. Handheld aspirators are particularly useful when field testing and calibrating devices such as pressure switches. As the name suggests, signal reference calibrators can output a variety of electrical signals. There are many different types of signal reference calibrators available to produce electrical outputs, such as voltage, current, ohms, frequency, etc. Many signal reference calibrators are capable of simulating thermocouples and RTDs as well. This type of calibrator, often referred to as a simulator, can accurately reproduce a sensor output and display that output in the variable units it represents. For example, a calibrator can produce the required ohms value of 212 ohms corresponding to a PT 100 RTD at 300 degrees Celsius. And, just to make them more versatile, many signal reference calibrators also perform measurement functions similar to a digital multimeter. These multifunction calibrators are very useful. For example, a thermocouple transmitter can be calibrated across its entire temperature range using the thermocouple simulation function of the calibrator. The user selects the thermocouple type on the calibrator and enters the required simulation temperature. The resulting transmitter milliamp current output is displayed by the measurement function of the calibrator. As a troubleshooting tool, a multifunction calibrator is invaluable. With a few quick measurements, a field tech can determine if a fault is caused by the sensor or the transmitter. Source and simulate are two terms commonly used by calibrator vendors to describe modes of operation. Let's have a closer look at each function. We've already touched on the source capabilities of a calibrator. Earlier, we said that a signal reference calibrator can produce electrical outputs such as voltage and current. In source mode, the calibrator generates calibrated signals for testing and calibrating process instruments. In simulate mode, the calibrator replaces or simulates a transmitter in a 2-wire loop configuration. The calibrator can be adjusted to supply known settable test currents. Okay, let's look at how calibrator source and simulate modes can be used in troubleshooting a 2-wire current loop. Our loop has a power supply and a 2-wire transmitter connected in series with a PLC analog current input module. The 4 to 20 milliamp signal flowing in the loop represents the process being measured. Alright, let's disconnect the PLC from the loop and connect it to the calibrator in source mode. Now we can test the PLC input by adjusting the current output from the calibrator. Let's have a look at how the calibrator is connected in the 2-wire loop in simulate mode. In simulate mode, the transmitter is disconnected from the 2-wire loop and the calibrator is inserted in its place. Now we can simulate the 2-wire transmitter by adjusting the current output from the calibrator. If you want to learn more about calibration in 2-wire loops, check out our other videos called What are 2-wire and 4-wire transmitter output loops? What is sensor calibration and why is it important? And DP flow transmitter testing and recalibration. You can find the links to these videos in the description. Okay, let's review. Instrument calibration is an adjustment or set of adjustments performed on an instrument to make that instrument function as accurately or error-free as possible. Instruments require calibration because equipment degrades over time. After maintenance to ensure that equipment conforms to calibration data. When the calibration range is changed. During or after troubleshooting. The 4 different types of instrument calibrators are block, fluid bath, pneumatic, and signal reference. Source and simulate are 2 terms commonly used by calibrator vendors to describe modes of operation. In source mode, the calibrator generates calibrated signals for testing and calibrating process instruments. In simulate mode, the calibrator replaces or simulates a transmitter in a 2-wire loop configuration. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.